Okay, so before we go down to that, what do you think a three-dimensional slice, which would basically be the same as a single plane passing through a three-dimensional cube, so a three-dimensional slice of a four-dimensional cube standing on its corner, what do you think that's going to look like initially?
Well, like initially it's just going to be a point.
Okay.
And then you might get like a triangular pyramid or something that grows until a point, and then it gets truncated into something.
Okay. So rather than waiting for these ones to be made, I actually made them down here. All right, so there's the first one above. It's not a point, so you can rotate that around.
So it's like a sort of a tetrahedron.
Okay. So it looks like a small tetrahedron. And this, in a four-dimensional cube, how long is the space diagonal if the side lengths are 1?
It'd be 2.
2. So this is, if I remember right, let's see, this is 0.1 up. So this is 1. The middle of the cube is going to be at 1. So we're 1/10 of the way to the middle of the cube. So scroll down now. So what do you think you're going to see as we move up another 1/10?
Oops. So that would be like this one?
Yeah.
So just a bigger tetrahedron.
Okay, bigger tetrahedron. So rotate that around a little bit. Is it a tetrahedron?
Maybe not quite, but it's definitely like a triangular pyramid.
Okay. What makes you say it's not a tetrahedron?
Well, just from looking at it, these two edges look longer than this one.
Okay. I think it probably is a tetrahedron. Remember, we were seeing things that looked like equilateral triangles when we came through. So go down with the scroll bar to the next one. Now we're going to be 0.3 along. So what's happening?
So tetrahedron is just getting bigger.
Okay.
Bigger and bigger.
0.4 along.
And it looks like here it might be starting to get to the point where the corners are getting shaved off.
Oh yeah, why do you say that?
It looks like it a little bit. Maybe that's just the picture rendering.
Scroll to 0.5.
0.5 is just getting bigger.
Okay, you see any corners getting shaved off?
Not yet.
All right.
Must have just been the rendering of that picture.
0.6.
Oh, here we are. The corners are getting shaved off here.
All right, so what do you see here?
So we had a tetrahedron, and the corners of the tetrahedron got cut off.
Okay. And what's the analogy with the three-dimensional cube? What were we seeing happening in the three-dimensional
we
cube?
had a triangle, and its corners were getting cut off.
Okay. So that's 0.6 up.
And then just more of it is getting cut off.
All right. So why don't you explore this shape a little bit and tell me what you see?
So it's looking like what we saw in the two-dimensional version, at least on this side. And over here we have triangles, but yeah, that's where it got cut off. But on the original tetrahedron faces, we have the hexagon pattern.
Yeah, actually, this is interesting. This looks like it's a shape made out of hexagons and triangles. I wonder if that shape has a name. Anyway, keep scrolling down.
So here the cut-off bits are getting really large. That's becoming the main side.
Oh, wow.
It's turning back into a tetrahedron almost.
All right, well, move that one around and see. This is at 0.9, so...
This edge is that small edge there is gradually just going to get smaller and smaller.
Okay, and what happens when it's 0?
And then when it's 0, it's back to a tetrahedron. Again. Or is it? Looks like this one's actually an octahedron.
What's the difference between a tetrahedron and an octahedron?
An octahedron is two square pyramids that are just stacked on top of each other, or back to back. A tetrahedron is one triangular pyramid.
Okay. So go back up to the shape you thought before was becoming a tetrahedron.
So actually now, yeah, from this angle I can see it better. You've got a square and then the center piece.
Okay. So it's pretty neat. So the surprise in Kelsey Houston Edwards' movie was that the middle part was actually an octahedron. And when we scroll down to the bottom there, we actually see that octahedron, which is pretty incredible.
Yep.
That is, when you take a four-dimensional cube and you have the middle slice of it, the very middle, halfway up the diagonal, that three-dimensional slice is an octahedron.
Wow.
So we could somehow stack these things together to make a four-dimensional cube, because now we're halfway up the cube and then we would just make them going back again. Very different look at a four-dimensional cube. Pretty cool. All right, good job, man.